Hey guys, this is Mr. H. I'm doing 23 from the benchmark exam, first quarter benchmark. Basically, this is a question trying to determine if you understand the difference between what it means to be a solution. So it says Ms. Rosano asked her students to explain why the point 3 and -4 is a solution to the equation 2y plus 3x equals 1. And they got 3 students responded. Andrea said, when the equation is graphed on the calculator, the point can be found within its table. Bill said that when you substitute x equals 3 and y equals a -4 into the equation, that gives you a true statement. And then Christine said that if you graph this line, that it passes through the point 3 and -4. And basically, which one of the students is correct? So I'm going to go through and I'm going to show you why each one of these students is correct. And I'm going to use the calculator to do most of it. So let me go grab the calculator. So the very first thing I'm going to do is, let's see, I am going to go into this. And first thing I'm going to do is I'm going to prove that Christine is right. And Christine said that the line passes through the point 3 and -4. So I'm not going to graph it as a function because it's not a function. I'm going to graph it as a relation. And I'm going to do 2y. Now, when you're in the relation mode, you can graph, the only 2 letters you can use are x and y. So I'm just going to put in the entire equation just as it is, 3x equals 1. And then I press enter. And it is a line and it is a function, but now we know it's a function. Now, when you have a line and it's in relation mode, there is no table available, but you can use menu 51, okay? And menu 51 generally will go to the y-intercept, but what we want is we want to see if the point 3 and -4 is on this line. So all you have to do is key in the x value. So the x value is 3 and then press enter, and it'll take you to that point. So if I click on this, it tells you that 3 and -4 is actually on this line. So any point that's on this line is a solution. So that means that Christine was correct. Now, I'm going to do the same thing to show you that Bill was correct. So Bill said, if you substitute in x equals 3 and y equals a -4, you get a true statement. So here's how I'm going to prove that. So I'm going to go here. Now I'm going to store I'm going to store 3 into x. So I'm going to do control variable. I'm going to store it into x, boom. And then I'm going to store a -4 into y, boom, right? Now, I'm just going to type in the equation just like we saw it, 2y plus 3x equals 1. Now, when you are using the equal sign, that's a Boolean operator. And all that means is that whenever you use equal or one of the inequalities, you're going to get a true or false statement. That's what a Boolean variable does. It either gives you true or if it gives it false. Now, if Bill is right, we're going to be substituting 3 in for x, a -4 in for y. When we press enter, we get a true statement. So that means that Bill is also correct. So if I go here, that also means that Bill is correct. Now, in order to see if it's in the table, we have to convert this equation to a function. So this is how we do it. We're going to get y by itself. So it's just going to be 2y plus 3x equals 1. Subtract, change the color. Subtract 3x from both sides. Boom. So we're going to have 2y equals 1 minus 3x. And then you just divide both sides by 2. So our equation is going to be 1 minus 3x divided by 2. Now, we can make this into a function. So now we can graph it. So I'm going to go here, I'm going to graph it, and I'm going to enter that equation that we just came up. So we're going to use the stack fraction, and then it's going to be 1 minus 3x over 2. So I press 2 here, right? Now, I'm going to go to the table, Control T. And then I'm going to look at the point 3, and you can see that the y coordinate is a -4. So that means again that this is true. So if we go back, we can see that Andrew was also correct. When we graphed it as a function, we found the point 3 and -4 in the table. So they were all correct. So the answer for this one is D. All three were correct. Now, and I'm hoping that you see you can graph this as a relation. You can do the algebra and get y by itself and graph it as a function, or you could just store the point that they gave you and see if the equation is a true statement. But any one of those ways will work. So I'm going to stop this and I'm going to post it.